So hello everyone. I hope you all enjoyed your coffee break. I certainly enjoyed the cookies. So I'm John Medland. I'm a certified LabVIEW architect, and I'm going to be basing a talk around how, as we develop our applications, we can maintain LabVIEW's strongly typed nature. So just before we start, I live and work in Manchester, and I love it. And one of our local heroes is Emmeline Pankhurst. Whilst not a member of the technological development community, she was very important in bringing around women's suffrage in the UK. She was arrested multiple times for this cause, and she basically dedicated her life to making sure that everyone in the UK was able to get the vote. So yeah, thanks. So I'm going to start with a statement, which is that LabVIEW is strongly typed. That's certainly something, as an electronic engineer, I sort of thought I understood what it meant and was quite happy to accept. But unfortunately, we're going to have to start with a little break to proceedings where I say the phrase strongly typed doesn't really have this sort of concrete, widely accepted definition. What we're really talking about when we say languages are strongly typed is that they employ strict typing and type checking. So strict typing is where we, so in the LabVIEW case, we have wires through which our data flows, and those have types. Those types are defined by the source of the wire. And we also have type checking. So as we're writing our code, the LabVIEW development environment is running the compiler in the background. And when it sees us doing an operation that would lead to undefined behavior, such as trying to add together a numeric and like a picture type, it gives us a broken wire, it displays that as an error in our error list, and it also breaks our run VI button. So we can't run the VI, and it's quite obvious to us as developers we've made some mistake. And the benefit of this is that it's built into LabVIEW. We don't have to write any tests. We don't have to think about it. It happens. And if we compare that maybe to a dynamically typed language, so with dynamically typed languages, you get more flexibility. You're not concerned necessarily with the types of variables when you're writing the code. But what it means is that the actual types of variables are only really known at runtime. So whatever just-in-time compiler or interpreter is used in this with your language, that's when your type mismatch errors will occur. So this is an example from JavaScript. So we start by creating our variable a, and we assign it the value of string. And that's obviously fine. We could do that in LabVIEW the same. Then in our next line, we go ahead and define a numeric value to that variable. And also, that works fine. And then just for this example, we create a second variable called b, and we give that a string with a 0 character in it. And then we go, oh, OK, well, what's a plus b? So we write a console log statement, and we see that it prints out the string 10. So what's happened there is that with dynamically typed languages, you also get this idea of sort of the language trying to work out maybe what you want it to do. But it's sort of an example of where you might see unexpected behavior because that language is is essentially having to guess at what you might want. So, I mean, if we try to add a number and 0 together, we might expect 1. But yeah, so why do we care? As you're producing your VIs, you probably don't think that you make these sort of mistakes. I mean, especially with the normal typing in LabVIEW, you can't. But there might be cases where we break this system. And the real issue is, as we go into refactoring, so we look at code that we have written, and we need to improve it in some way, typically to make it more maintainable or easier to understand, or as we learn new techniques, which we think will improve how the code works and operates, we make changes to our code. It's very easy when making those changes to maybe not remember the implicit relationships between different data types or different areas in our application. And that's when we get type checking there to save us a lot of hassle with making these sort of silly mistakes that will catch us out at runtime. Now we go on to strict typing loopholes. So it's these loopholes which is why the term strongly typed is kind of unclear, because the answer is, if a language has strict typing but has loopholes, is it still strongly typed? Because you can kind of break your strict typing system. So when we use these loopholes, we're sort of making a decision as developers. We're saying we're going to leave the nice warm embrace of type checking, and we're going to wander out into the sort of barren wasteland of runtime type mismatch errors. That might be a bit drastic, but anyway. So each loophole is generally based around some form of data abstraction, data type abstraction. So whilst we're dealing with things in this abstract data type, it's quite straightforward. It's often very easy to convert real types, like numerics or clusters or whatever, into these abstract types. And when we can keep them as these abstract types, life's pretty sweet and easy. The problems we encounter are when we need to go back from this abstract world into real types, our real data that we need to actually do some operations on. And I'm going to look at a few examples now of where we're sort of deploying this data type abstraction and sort of think about why it might be happening and why we might be doing it. So the first area I sort of identified really was our drive towards reusability. So, I mean, hopefully everyone understands what we're talking about here with reusability and why we like it. It's much better, in my opinion, certainly, and I imagine it's shared, to write code once and be able to use it all over the place, because it's not just the writing of the code, it's the testing, it's the debugging, it's the maintenance. And if you can do that once and use it everywhere, then that's made your life a lot easier. I mean, even better if you can use someone else's code, because then they're doing all that and you just get to benefit. And it's not true that all reusable libraries will use some form of data abstraction, data type abstraction, sorry, to work, but lots of the common ones that we might encounter, like, for instance, sort of messaging or maybe sort of state execution frameworks, will employ some form of data abstraction. And I've got a couple of examples that I'm going to show you. This is a sort of a previous to Malleable VIs, but we used to be in a world when we were creating a VI that we wanted to basically handle any data type. We'd be sort of hamstrung by what we could do. So you might know with lots of LabVIEW built-in nodes, you get this sort of ability to wire any data type in, and it will just work. And all the types propagate, and it's great. And unfortunately, until Malleable VIs came along, we didn't really have that ourselves as LabVIEW developers. So the best we could do was maybe create a polymorphic VI with as many VIs as we could care to make that would handle the built-in types, which we could expect, maybe like I32s or doubles, whatever, even arrays of those types. But you always had to deal with these sort of aggregate data types, like clusters and maybe weird arrays and other structures. And trying to make a VI which could handle these was really only possible by using this data abstraction. And the answer was use a variant, which can accept any data type, which would be our wire into the VI, and then the data coming out would also be in a variant, but we'd know that we'd have to convert it back to the actual data type that we're using. And I think, to be fair with this example, it's probably quite easy to see what the relationship between the input and the output data is, and that it's quite well contained with regards to where our type loophole sort of goes. It only exists between those two VIs, so it's not too bad. And I mean, the benefit of LabVIEW 2017 and onwards is that we now have malleable VIs. So we get that magical adaptive data type, which makes creating reusable libraries easier. And for stuff like this, they're sort of really, really good. So another example we might see is with our messaging libraries, or maybe with our sort of like queued state type libraries using strings. So if we think about when we first create state machines, like our state is typically decided by an enumerated numeric. Like, it's quite handy. You can use nice, readable words to represent a number. And if we make changes, especially if we use I should say, type-defined enum, when we make changes in one place, we can track those changes through. We can apply it in other areas. And we're not at the risk of typos, which is certainly something that I made a mistake with, or like if we choose to rename a state in one place, we have to remember that, oh yeah, we're referring to it in other bits in the code, so you have to go through and make those changes. Yeah, but when we want to make a reusable library for these sort of things, well, if we used a type-defined enum, we'd basically be saying this library can only support these message names, these state names. So we'd sort of be stuck. So in the end, we go for a string, which means we can wire in any name that we want, and the library is much more flexible. And I had a little go at playing with malleable VIs to try and make the messaging library work, and I think it works, but it's not the easiest thing to do, and certainly malleable VIs have certain constraints on their execution, so they have to be inlined, which means that you might not be able to use them for things like functional globals, but I've not really played with them very much, but that's just sort of where I'm currently at with that. But yeah, so certainly these, there might be something we can do, but these strings are still maybe, are certainly a loophole. And then I'm afraid this example is really quite oopy, but I wanted to have an example from the object-oriented world. So this is concerning the actor framework, which some of you might be familiar with, I don't know. So just to sort of take it step by step, the actor framework is based around actors, which communicate with each other asynchronously using messages. The framework itself is an example of the object-oriented command pattern. So in actor framework speak, a message is our command. And the benefit of OOP in this case is that we get to encapsulate both the data required to perform that command and the implementation of the command itself. So that should actually be really good in terms of strict typing. We don't have any need to abstract our data to pass it through some channel or anything. It works. The problem with the actor framework, and I imagine other libraries of its kind, or other frameworks of its kind, is that it relies on this sort of shared reuse library for the actors' inner workings. So what this means is that when we're sort of describing actors in those libraries, we're using the generic base actor. And what this means is when we come to actually execute our command, so in actor framework world, that is when we call the do message, the do method within a message class, we have to downcast to a more specific class. And what this means is that essentially if we send a message to an actor which isn't actually meant for that actor, then we can encounter this runtime error. There's no way of the type checking being able to understand what's going on here. So yeah, that's sort of an example that we see within, even within OOP. So another area where we might be using these abstracted types is when we're sort of hamstrung by the implementation we've chosen. Typically, when we try and create a library, we sort of want to hide all the nitty-gritty of how it's doing what it's doing underneath our sub-VIs. But it's sort of difficult or sort of inevitable, or you've chosen a model where you will leak details of the implementation up to your top level. So we see this with things like using the data field within a message. So typically we'd use a variant. Some people use strings. So here, because we've chosen to use a LabVIEW queue for messaging, we know that LabVIEW queues can only take one type. We assign it when we create the queue, and then we can't ever change that type. So if we want to be able to send messages where we can bundle along with our message name any arbitrary data, we're going to have to use this sort of pattern. And it's easy to send a message. You just wrap your data up in a variant and fire it off. But when we come to dequeue and handle that message, we're really relying on a sort of an implicit link between what data we expect to be in that variant and the data that we actually get. And that's a sort of another example where you might see these runtime type mismatch errors. So, I mean, the question is you know, what are we going to do about this? Is this a thing that we can fix? So I'm going to look at those two areas of reusability and implementation next. So yeah, the first thing is we're going to have to probably rethink our sort of idea of reusability. So typically, reusability, you've got some VIs within your project that can be shared between, that can be used by anything in your project, or maybe you've even gone as far as using a VI package or some other packaged code method and got those VIs installed, maybe even in your VI library file. So then they're shared across all the code that you write. But unfortunately, as soon as we start adding concrete types into our library, we no longer have this reusable library in the same way. We've really got to, we've created a custom library. So we're sort of having to move away from just having this one, or this group of VIs that live in our VI libs directory, and moving more towards the idea of relying on templates and VI scripting. So we don't have to start from scratch every time that we want to, essentially create a custom typed library. We can use templates, and then to help with making the modifications that we as developers would need to make, we can add sort of VI scripting routines and automation. So obviously the problem now becomes, like, you can create your customized library, you can script it, it's great, but then you realize, oh, I'm not super happy with how I implemented that, or, oh, I'd like to add this feature to the library. Well, now you've not got a single source of code to fix. You've got, like, all the copies. And, like, managing that can be quite tricky. So if you're able to, and then I'd certainly advise creating some sort of migration method for the code that can make that much easier. But this is essentially what you're saying is, I used to have reusable libraries, and now what I have is customizable libraries and a whole load of other code that I have to build and maintain to make them sort of work. So that might actually be a deal breaker. You might just accept that you're going to take those runtime errors and deal with those sort of debugging relationships over putting this considerable time, effort, whatever in. But there are some things that you can do to make your life easier if you're going to be using templates and VI scripting. And that is, it might help if you break down your reusable library into smaller parts. There might be a case where not all of your VIs are actually linked to the sort of custom typing element. Some of them might just be, like writing just a text line to a file. It doesn't actually have to be customized. And what I suggest there is break those out into separate libraries, which you can then install or use on a sort of project-by-project basis. The other thing is, if you are going to be doing scripting, then basically whenever you have any sort of type, just put it in a type def. Scripting type defs is so much easier than trying to sort of construct controls as you script. So there's a few things we can do to make our life a little bit easier. And so the question is, could we apply this technique to the active framework, which could kind of be strictly typed? And the answer is sort of yeah. So it would look something like this, where instead of having sort of a collection of actors which all use the same internals, we'd have to duplicate those internals for every actor type that we create. So, it could be done, but this probably isn't the right way to go about it. Firstly, because the actor framework wasn't designed for this kind of templating and scripting method. So it would take a lot of work to get it to a point where it would play nicely with that. The other thing is lots of the tools which make the actor framework so usable are designed around how it currently is. So lots of those wouldn't work. And that would make developing with the active framework sort of much more onerous until those were changed or you built your own. But you know, there are some frameworks out there that make lots of use of templates and scripting. I mean, I see Fab right in the front row, so this is a bit scary. But so the DQMH is a really good example. So, I mean, correct me if I'm wrong. So it's sort of based around the NIQ'd message handler sort of style or architecture, and it uses actually events to do this strict typed communication between different asynchronously running modules. And when you create a new DQMH module, there's lots of, that's sort of based on a template, and there's lots of scripting going in the background to generate and modify that template for your needs. And I mean, one of the key things with this tool is ultimately the DQMH validation tool, which helps validate and sort of manage the migration from one version of the DQMH to the next. So obviously it can be done, but sort of looking at the DQMH as an example, we do still see another implementation of a loophole. It's not a criticism. I'm not criticizing it. It's fine. It's sort of like, yeah. So as we see, we much like the standard National Instruments queued message handler, we're using our string variant messaging to send messages to our message handling loop. So that brings me on to the next thing, which is, can we rethink some of the implementation? Or another way of putting this is, like as a more inspirational format, is leave behind what holds you down. I found an image and thought it felt quite peaceful. So I mean, if you want to really tackle this head on, if the problem is that a queue can only take one type of data, well, try just adding more queues. Yeah, if you create a queue for every message type, which we're doing on the left, and then you can just sort of bundle them together and handle them as a big cluster, it's quite easy. The problem is the other end when we come to dequeuing. So now instead of dequeuing from one source, we've got lots of different queues, and so you need some method where you're going through and sort of polling to see maybe which one has a message that needs reading, and doing the priorities and execution. Working out the priority of messages is tricky. But I mean, of course, I wouldn't raise the topic if there wasn't something we could do. So the question is, could we extend user events for our main message handling loop? And the answer is, yeah, it sort of looks very similar in a way. We still have our creating of queues in this time, except this time they're user events. We have to make sure that we register on those events before we start sending stuff. But once we've completed those acts, we then get to handle our cases within our event structure instead of our typical case structure. And as if by magic, the types all flow through. So now dialog, which is a string, appears as dialog in a string, and you don't need to use any variants. So obviously the problem here is creating these user events can get quite boring if you're putting lots of messages in, but as we've seen from the DQMH, but also lots of other libraries, especially ones with the active framework, like lots of people have done automation of inserting events, and yeah, it just makes life so much easier. Now, as I'm wanging on about events for a bit, I thought I might do a bit of a deep dive into them, mostly because if you're not into this whole strict typing thing, you might still find something interesting, but hopefully you're all still on board. First thing is the dynamic event registration node. So I think when I first saw this node, I only ever wired like a single reference in. So maybe if I was doing dynamic events from something like a control, you'd wire the control reference in. But in this case, we're using user events, so I wire that reference in. So that's the top left-hand side, just a single user event into our registration, register for events node. But we can also extend this node down and wire in multiple different event sources. The node will also support clusters of event references and also arrays of event references. So that creates really interesting flexibility with how we might aggregate messages or just how we're going to pass groups of user event references around. And then the next thing that is interesting is, so when we get our event registration, we typically wire that straight into our event structure using the dynamic event nodes, dynamic event terminals. We can actually create a cluster of event registrations and then work with those. So that has ramifications for if we're going to be maybe dynamically within our event case sort of unsubscribing or deleting event references, then that we can make life much easier or harder for ourselves. And the other thing that I find interesting is as we create this sort of more complicated structure of clusters and arrays and all sorts of things, we can see that we sort of slowly get this expanding name within our event case, which gives you some idea of the hierarchy, and it's sort of tied to lots of the names of the clusters and then the owned names of the wires. So yeah, it can get a bit confusing, and it can be very frustrating when you create an event and you're like, oh, I don't like that name. Oh, I have no idea where I can change it. But it's not impossible. Once you crack the secret of it, it's actually pretty nice. So the next thing is thinking about the lifetime of user events and event registrations. So with a typical LabVIEW queue, you sort of have a single queue, you create it, you use the same reference to enqueue and dequeue, and then when you're done with it, just close it. With user events, we create our user event reference, and then that's the reference we use to send events. But if we want to receive those events, we have to create this other thing, this event registration. And the order that you do these things is quite important. If you want to, you can only receive messages once you've registered, or you can only receive events once you've registered on your user event reference. And the other interesting thing, if you're maybe doing some sort of asynchronous reply, is that you can close your user event reference, and your event will still exist within your registration. So the registration sort of creates a queue in the background, and that only is destroyed when we manually destroy it, which we do right at the right-hand side with that VO there. Yeah, so that can be handy if you want to, essentially, you've created a user event to send back a message or send back some data. And once you know that the recipient has registered on it, you can then send the event and close down the reference. You don't have to worry about the receiver closing down the reference. So it sort of makes a few more of these, essentially it gives you a few more options with how you might manage references and lifetimes within your application. So the final topic, are we going to do final topic?
And the flush allows to delete only certain types.
Sorry?
And the flush, as opposed to regular queue.
Yes.
It allows to delete only certain types.
Exactly, yes. I haven't even gone into that. Yeah, the event flush is another interesting VI for, sort of filtering out events that you might not want. So one of the things that I also like with events is I like lots of architectures where you have multiple clones of things. And if those clones all have the same interface, so maybe they all send out an error on a user event. So if you launch those clones, you can bundle up all that sort of an array of user events and then register on them in one go. And then when it comes to working out which of those clones sent an error, you can use the user event ref inside our event structure. So we get it in as a terminal. So we can then do a lookup. So if you're in LabVIEW 2019, why not play with the brand new map feature? So because you can wire anything in as a map key, it works really well for references, and you can just, I don't know, reference that against a name or something. Or if you're in an older version of LabVIEW, do an array search, get an index. That index should hopefully link to some other array with some other names in. Yeah, so I really like this for those kind of multiple sources of event, all sending errors into the same case. So, I mean, the alternative would be is that you'd have to sort of add an event case for each sender, and that could be just code duplication that you don't need. So, yeah, and this is one that I only learned recently by peering inside the JKI state machine objects VI. And then the final thing on events is memory usage. So if we think about our classic LabVIEW messaging queue,
That's wrong.
is that wrong?
Yeah, this is from an old presentation that Jack Dunaway did. And when he did that, that was before 2013.
Okay, that's now fixed.
Has been fixed since 2013.
Oh, good news, everyone. Do this all you want.
So, and what happens is when you try to reproduce it, you use probes.
Right.
So you're artificially keeping the reference in memory, and that's why you see the leak.
There we go.
So you need to use a different method. Either, write to a file, something else, so the observer doesn't change the observee. So let's skip that because
yeah.
I like
No, absolutely. Yeah, I'll just chuck that in the bin right now. No, that's great because this being able to register on a big cluster and not worry about events that you're not caring about makes life so much easier than having to register on each one. That is really good. Thank you for that. So putting lots of these things together, could we make ourselves a queued message handler with strict typing? The answer is yes. Is it that remarkable? No, it kind of looks like the normal queued message handler. So what we've done on the left-hand side is we've just wrapped all those event creations inside a VI. We must make sure we register first before anything else happens, including like sending our initialization method. Yeah, so you do that, and then obviously you replace the typical case structure inside our message handling loop with an event structure. And we can register the events that we want. So the difference maybe here is that with our case structure, we'd have maybe a default state, especially if we're using string messages. With this structure, essentially, if we don't create the event case, then that event, it happens, but no one's listening to it. There's probably some like tree falling in the woods type thing. And I guess there's no memory leak, so yeah. Yeah, so that's it's certainly doable. Whether it's something that we're sort of interested in doing as a community, or just I don't know. I'm still sort of trying to work out what bits of this I like and what I don't. And sort of towards that end, I've been sort of putting some thoughts into a sort of library I've been creating. So it's currently on a GitLab. If you want to, the easiest way to find it is probably via my websites. So that's sort of me thinking about the architectures I like building, which are these sort of asynchronous, I guess essentially they're probably actors, but they're sort of more around the queued message handler type thing, and then thinking about like how we manage references and all these other things, and how I might like to build sort of these different components and handle packages and all sorts of stuff. So that's kind of there. If you're interested, feel free to take a look. Maybe you want to contribute something. Maybe you just want to send me some abuse as an issue. That's fine. Yeah, please go for it. So I'm now going to move on to questions. I've kind of raced through, so if there are any questions, I'll try and answer them as best as I can. Yeah. So, sorry, I've got a summary. I've got a summary. Sorry, stand down, microphone folk. So yes, common design patterns and libraries use these data abstractions, which lead us away from LabVIEW strict typing. And it's possible to bring it back, but we'll have to think about how we've been making use of reusable code, or that whole thing. And we have to think about what implementations we're choosing, because as we saw with queues, it can cause some problems. Finally, you might be able to catch all the runtime mismatch errors. I'm sure that means your code will run fine. No one ever puts bugs in code, so it's not a problem. But you could still get other errors, so please still do testing. Write your unit tests or do some sort of TDD. But yeah, at least you've missed some of the maybe stupid stuff that'll catch you out at runtime. So yes, I'd just like to say thank you very much to all the organisers. I'm really excited to be here. It's been great to present, and I'm now going to take some questions. So sorry, back on duty, microphone people.
Can you go back to your message handler?
Oh, right. Yeah, I can probably do that. You mean this one?
That one, yeah. Hello?
Hi.
Why do you have 2 loops there?
This is a thing that I've been really thinking about. Yeah, I quite like having 1 loop, but you're really accepting the whole idea between, like, do I care about decoupling of various different levels? This adds a nice sort of like protection layer against external calls. Sorry, it looks like Fab has a point. If I can defer to her. Yeah, yeah.
Because the one issue that you have with events is that they can get chatty. So if you have somebody sending tons of events, you might not be able to service all your events.
Yeah. Sorry, yeah, if you wouldn't mind
So what I
repeating that.
said is the reason to have multiple loops within event structure is for prioritization of events. If you have an event that is chatty, that is sending too much events, it can flood the queue, and then you don't get, and when everything gets in the same queue. So that's one of the approaches that we have with, we call them helper loops in DQMH, but that's the reason to have multiple loops.
Yeah, it looks like James is going, thinking.
That's why Fab would have 2 loops, but that's why you would have 2 loops. And I think it's because, and it's a bugbear of mine, that in LabVIEW we are a bit over-focused on this kind of producer-consumer thing.
Certainly for really simple things, like if, I made a little example that was like a login pop-up. So essentially that's mostly driven by user events anyway, so the idea of having like 2 loops probably doesn't make sense. But for bigger applications, especially because your bottom loop's going to be doing stuff that takes a bit more time, you should imagine as though it's a case structure. You're just using events because it's a nice implementation for messaging. But yeah, that's a really good question. Thanks very much.
I mean, I would never allow this kind of structure in my application. If someone was working under me, I would have them do a 1 loop thing.
So I think I've seen your presentations. You prefer having the sort of side-by-side. You have your event handling, then you have your sort of message handling.
I just want to point out that you have kept this, even though you had no actual reason to keep this.
Well, yeah, no, that's a good point.
It's all right to have 2 loops if you have a reason to have 2 loops.
Yeah.
But why are you having 2 loops?
Oh,
it's an overcomplication if you have no reason.
And yeah, absolutely. Certainly, you know, this is an example sort of based on the QMH architecture. But yeah, please, I guess it's back to the like sort of brainless coding stuff. Think about what you're doing and what you really need. Like 2 loops can sort of overcomplicate things in this style. And if you've got lots of shared data and stuff between them, you know, maybe some sort of flatter shared structure is the way to go.
Well, then you're into shared structures between loops, which is
a
whole new kettle of fish. Don't overcomplicate it.
That's probably the best point to take that question. But yeah, sort of summarize there. Thank you very much. So, I think we've got a question over there, if I can see.
I just want to understand a little bit better this discussion. Do you understand? Do you understand correctly? This kind of design is safe as long as you don't have GUI events.
No, GUI events would be. I mean, assuming that your GUI controls are.
Because I have very bad experience with 2 event loops in the same VI handling different GUI events. They always hang. Yeah,
so I see Fabiola wants a point, but maybe I can try answering it, and then we can just go back to her because she has, you know. Certainly, you'd have to employ some discipline between where you're handling your user events and then treat your message handling structure loop or you know other thing as like a sort of your message handler. It doesn't care about the user events. But I mean, if Fab's got some point on that.
So the LabVIEW helps us not to register for the same event more than one place. People have misinterpreted that to meaning that you cannot have the same event. What you need to have is to have 2 separate registrations. So you can register implicitly by saying, I am registering to a control value change, or you can take a reference of your control in your GUI, create a reference of that, and then wire the reference to the user event.
Yes.
So even though you're handling the same control event, you have 2 separate registrations. And an example of that is on TLB and TLB prime from Norm, where he has an outer event structure that is registered to an array of references.
Right.
And he does that so he can cache all the values, and that's how he addressed the 2 loops and having access to the arguments. And then in the inner event structure, he registers implicitly. So you can register, but you have to use references and always keep the register for events and the show dynamic tool one-to-one relationship.
Yeah. That's a great point. Thank you very much. Has anyone else got any more questions? Oh, I think we've got one over there, unless someone else has.
Have you got any comment on the efficiency between using an event structure as a queue and using the input queue as a queue? Is one significantly better or worse than the other, or it makes no difference?
Well, I mean, certainly if you imagine you had a single queue full of elements versus multiple queues with just like one event in each one, then you've got all the additional memory overhead of having those different queues. I mean, I don't know how it might work on a real-time system that's really low on resources, but you know, sort of, if you're on a PC with bigger resources, I wouldn't worry about it too much. Maybe if you're sending large amounts of data and you have many different types of messages, then you might be looking at that sort of case a bit differently. Yeah, I feel the need to just go over to Fab. Maybe she has some point on this, but. So,
I don't know if the presentation is still up, but Jack Donaway did a presentation about 5-6 years ago, and he did do a benchmarking.
Yeah.
For the most part, events and queues keep up with each other. If there is always a place where you start losing that, in that case, then you either, you can send a reference to a DVR or a reference to a queue or something else, and it still will keep up. So
yeah.
It really boils down to the size of the payload. But if you benchmark them for like 95% of the applications, they're going to be equivalent.
Great. Yeah, thank you very much. Oh, and then we've got a question behind you. If you can just pass the microphone back into your left.
Yeah, I was just wondering if you have looked at exploiting the fact that the events are one-to-many communication while the queues are one-to-one, or if you try to keep yourself from doing mistakes due to that fact.
I haven't looked at it sort of where I'm at with thinking about these things. It's certainly an option available to you, and the benefit of having this sort of strict typing means that having that one-to-one pattern sort of works quite nicely, because you've not got to think, oh, I've got even more sources where I need to make changes if I change my types. Yeah, I'm sort of, it's not really an abuse of the event messaging event system to use it this way, but it's just, it's sort of, you have to sort of consider it a bit separate from the normal event structure. I guess some of the problem is that we talk about events in software with a certain paradigm, maybe around sort of subscriptions and brokers and like this full dynamic registration stuff. And this is kind of, I'm not really in that, I'm not sort of looking at that just yet, but it's certainly something that would be interesting to look at. I'm absolutely sure. So thank you. Hopefully that answered your question. I don't know if we have anything else. It's really hard to say from the stage. If not, I guess I'll say thank you very much, everyone, for your attention and your kind comments and whatever. Cheers. Thank you.